Unit 8, Day 3, Determining Equations of Special Lines. So remember from the last unit that parallel lines have equal slopes and perpendicular lines have negative reciprocals. Also remember that horizontal lines have equations in the form of y equals a constant, and vertical lines have equations in the form of x equals a constant. So today we're going to show you how to figure out the equations for these special lines algebraically. So let's get right into some examples. So example 1, determine the slope y-intercept equation of each line. So the first line they want us to figure out is a line that is parallel to y equals 2x minus 11 and goes through the point negative 3, 4. So first, let's write out our form of the slope point line. So y is equal to mx minus p plus q. Can we plug in our slope? So if this line is parallel to this line, we know they should have the same slopes. So we can plug in 2 for our value of our slope. And then we can plug in negative 3 and 4 for p and q, because they represent a point on the line. And now we simply simplify this equation. And now we will distribute the 2 inside the brackets and simplify one final time to get our slope y-intercept equation of the line. Part B, let's find the equation of a line that is perpendicular to y equals negative 4 over 3x plus 5 and passes through the point 1, 9. So we know that perpendicular lines have negative reciprocal slopes of each other. So if the slope of line 1 is negative 4 over 3, we know that the slope of our line has to be the negative reciprocal of that, which is just 3 over 4. So again, our slope point form. Now we can plug in our value for m. And then this point that it goes through, 1, 9, we can plug in for p and q. And now we simply distribute the slope inside each bracket. And now we simply distribute the slope inside the brackets. And finally, to combine these two, they both need to be fractions out of 4. And one last simplifying step. And that is the line in slope y-intercept form. Part C says, find the equation of a line that is parallel to y equals 5 and passes through negative 3, 8. So y equals 5 is apparently a line that is parallel to the line we're finding. So y equals 5, if we graph that, it looks something like this. It is a horizontal line going through y equals 5 is that y-intercept. So if it's parallel to this line, it must have the same slope as this line. And we know that the slope of horizontal lines are always 0. Therefore, the slope of our line must be 0 as well. So y equals m x minus p plus q. We plug in 0 for m, and we can plug in these values for p and q. Now we must simplify. And now distribute 0 inside the brackets. So we get 0x plus 0 minus 8. So y equals negative 8. That makes sense. It's going to cross the y-axis at y equals negative 8. So we have another horizontal line. So the final example says, find the equation of a line that is perpendicular to y equals 3 and passes through the point -1, 5. So we could go about this the way we have been, in that we plug in our value of our slope and point into the slope point formula, and then simplify to get our slope y-intercept form. However, there is a quicker way to solve this, and I'm going to show you how. The first thing we need to recognize is this line is a horizontal line. So if you don't understand that, look here. So y equals 3 is simply the equation for a horizontal line that goes through the y-axis at 3. Okay, so you can see it's horizontal. Now if our line is perpendicular to this line, then we know our line is a vertical line, because a vertical line is the only thing perpendicular to a horizontal line. Now recall that the equation of all vertical lines are in this form. X equals a constant. So if our vertical line has to pass through this point, then the x value of our point is our value for A. So here's the point that it must pass through, -1, 5. So therefore -1 is what we plug in for A, and there is our equation for the line. So sometimes there are easier ways that we can go about problems like this. They just require a little bit of thinking outside of the box.